The last exponent law we're going to learn for grade 9 is called the power of a quotient. And we've sort of seen this as we worked through our review unit and in the quotient clause earlier. But let's give some examples and see if we can pull out the general pattern. So the first one I want you to look at is 2 squared over x cubed, x cubed, all to the power of 4. So if we were going to expand this all the way, we would have 4 of this bracket. So 2 squared over x cubed So that's my expanding. And then now we're just multiplying a bunch of fractions together, and we know that when we multiply fractions, we multiply all of the numerators together, and we multiply all of the denominators together. So this is just simply the power of a product, right? The first one, the product rule. So product rule means I just add the exponent. So it's going to be 2 to the 2 plus 2 plus 2 plus 2. All divided by x, 2 plus 3 plus 3 plus 3. So we've got 2 to the 2, 4, 6, 8. And x to the 12. Now, to saving us having to write out all of these brackets again, because that's sort of onerous, it takes a lot of effort to write them out. How did I go from 2 and 4 to 8 and 3 and 4 to 12?
You just multiplied it by the exponent outside the bracket?
Perfect, that's all I'm doing. This is just like what we learned in this rule here. So we took the stuff on the exponent on the outside of the bracket and we applied it to the inside. But in this case, the inside is just a fraction, a division question instead of so it's basically the same as the power of a product, but I need to apply it to the numerator, the top, and the denominator, the bottom. Like this. So let's see what that looks like. So AB squared over C cubed, just a little bit. We can use whatever letters we want. It's totally up to us. To the power of 5. So I'm going to take this 5 and apply it to every single base that's inside of the fraction, inside of the brackets. So 3 different things get multiplied by 5. Power rule, right? I have 2 exponents right beside each other, so we multiply them together. So we're going to have a to the 5, because it's like 1 times 5. B squared to the 5 divided by C cubed to the 5. Right, we just take that 5, instead of putting it on the outside, we put it on all the parts on the inside. So we're left with a to the 5. We know that when we have 2 exponents right beside each other, they're on the same base, right? We just multiply them. So 2 times 5 is b to the 10. And then 3 times 5 is c to the 15. Okay, again, this is just the power of a power rule, but we're using it inside of a bracket. You do this last one. 3x squared is the numerator, and y to the power of 4 is the denominator. So what do you get? I'll give you a second to finish that. Oh, sorry, it's all to the power of 6. What else are we supposed to do with this?
Is she giving us a tricky one? Yeah, me too.
You're always allowed to ask. Nope. There are no dumb math questions. You can ask me questions, but not math questions. All right, check yours against mine. What is 3 to the 6? Not quite. And you might need your calculator for this. It's a pretty large number. Robin, did you do it?
No, I was
Trying to think it through? Absolutely. Like 700s, so you might need a calculator.
Really?
Yeah. And yeah, because it's 3 times 3 times 3 times 3 times 3, 6 times.
Yeah, I know why you got confused, probably because sometimes like if it's like 2 and 6, you would multiply 2 and 6, so like 12. But like when it's the 3, you don't do 3 and 6.
Exactly. Easy to like,
Yeah,
if you're not paying attention, just multiply them together.
Because that's what I was about to do first.
And then 4 times 6 means we're going to have y to the power of 24. Okay, so let's write this like statement down so you have this final rule. When taking the power of a quotient, we apply the exponent to everything inside, to all parts, so the numerator and the denominator. This is basically the same rule as the last one we learned, except now it just looks different inside the brackets because it's a fraction instead of a multiply. When taking the power of a quotient, or when finding, apply the to all parts of the numerator and denominator. We'll use m as our exponent on the outside. X times m over y times m.